Hello physics students. Today we're going to be doing an experiment called Ohm's Law Lab. Now the purpose of this lab is to determine the resistance of a resistor using Ohm's law. Now at this point you should have already printed out pages 3 and 4 of the lab sheets. As you can see, this is where you'll be doing recording your data and doing your analysis and also answering questions. Page 1 is instructions. As always, you don't need to print it out unless you want to. So let's have a closer look at the equipment we're going to use to achieve our purpose. To achieve this purpose, I'm going to use a power supply, something called a proto board, 2 multimeters, I already mentioned what they are, some banana plug wires, which look like this. I'm not really sure why they call them banana plugs. Maybe it looks like a banana, but we're going to use 5 of these wires, and then 2 wires that are called banana alligator clip wires. This is obvious why it's called an alligator clip. It looks like a little alligator when you open this up to clip it onto things. And also a resistor. I mentioned what resistors look like when we're first talking about resistance. Here is one such resistor. Okay, so first thing that I'm going to do is I'm going to measure the resistance of this resistor by using one of these multimeters. I got to configure it to measure resistance. So what I'm going to do is turn this dial over here. Now it's an ohm meter. And then I'm going to put one of these wires into this plug port here and one here, because this has a little ohm symbol. So that's where I plug in a wire if I want to measure resistance. So then what I'll do now is just clip these 2 ends of these wires to the end of the resistor, and it will tell me the resistance of this resistor. So there we are. It's about 1,483 ohms. So I will write that into my data sheet in the appropriate spot right here. Once again, you're going to go into the sheet in the Google Stream to get your own resistance value assigned to you for this experiment. Okay, so now what I want to do is set up a circuit that in which I can measure the voltage and the current at the same time. So that's where this comes in, this what we call a proto board, or sometimes called a breadboard. See, this power supply, we want to link it to the resistor, but this doesn't really work to plug it in like this. So this board is designed to allow physicists or electrical engineers to make circuits up quickly for experimental purposes, and to change them quickly, because we don't want to use like soldering where we start melting metal to connect this resistor to other wires. So the way this proto board works is there's a bunch of holes you could plug wires into, and underneath this plastic the holes are connected in a certain pattern. All of these holes, these 5 holes going across this way, are all connected under the plastic, but these 5 holes are connected to each other but independent of these. So the connections are going this way. So one way I could connect this resistor to these posts is by plugging in this orange wire into this row. I could pick any row I want. And then I'll bend this resistor like this, and I'll plug this in to this hole right here. It could go into any hole along this row. Like for example, I could go there. And now this orange wire and this side of the resistor are connected to each other. Then what I'm going to do is plug this in somewhere, anywhere else on the board, down here. Now this resistor, this end of the resistor is connected to all these holes over here. So if I take this yellow wire and connect it to any one of these holes, what I've done is I've connected this post to the end of the resistor here, and this post to the end of this resistor here. That allows me now to create a circuit with a power supply. So what I'm going to do is take the electricity out of the power supply. Now remember, I've got to make a loop. So one possibility is I go like this, and then the other one, the other wire, I just bring to the negative terminal of the power supply. This is a loop, and the circuit would work The problem is that we would not be able to measure the current. So what I have to do is open this circuit up and complete it with what we call the ammeter. This is a multimeter here, but we're going to essentially configure it so that it measures amps. So I plug the wires into the right holes, and then all I have to do is turn this dial to the amp setting. Now I've got an ammeter over here, but I also want to measure the voltage of this power supply at the same time. So I'm going to take this meter, which used to be my ohm meter, and I'm going to now make it a voltmeter by just turning like that. Now it's a voltmeter. So I will now connect it using the right posts in the multimeter and just go straight to the power supply. And that'll measure the voltage of the power supply. Now I'm all set up. This power supply will drive current through this little tiny resistor over here, and at the same time we'll be measuring the current and the voltage over here. Okay, so that allows us to now perform our experiment. Let me plug in my power supply. Let's do a little test. All right, looks like things are working. So the first data point is that if you have 0 volts, you're going to have 0 current. Well, that makes sense. So in the data table, we already have that filled in. The next thing I'm going to do is I'm going to keep increasing the voltage and measuring the resultant current. Let me try, say, around 3 volts. I don't have to be perfect. Well, I hit it on the dot there, 3 volts. And I can see that this meter reads about 2.0. This is in regular volts. This is in milliamps. So I will write those down for 3.0 volts. I get well, now we got 2.1. All right, I'll say 2.1. So I filled those in to my data sheet, 3.0, 2.1. So what I want you to do is go into the Google sheet, the sheet I included in Google Stream, and get your own data point for the first voltage trial. All right, now what I'm going to do is keep increasing the voltage. So maybe I'll go to somewhere around 5. Let's see what happens. 5.2. Good enough. We don't have to struggle to get this to get exactly 5. So I'll write down the voltage here and the resulting current. 3.6 looks pretty steady. And there I've copied down the second set of data points. Again, go to the sheet in the Google Stream and retrieve your own data for the second voltage and current. Okay, again, I will increase the voltage. Maybe I'll go to somewhere around 8. Okay, 8.2 again. I don't want to waste time trying to get exactly 8. It doesn't matter as long as I record these accurately. 8.2 and 5.6. So there's my data. Again, you go to this the Google sheet, the sheet in the Google Stream, and record your third data set. Okay, again, I will up the voltage. Maybe what I'll do is go up to 10 volts this time. Okay, 10.5, fine. 10.5 and 7.2. So here are my data points. Again, go into the sheet I included in the stream and get your fourth data point. Okay, so this time maybe I'll go up by about 3 volts. So, well, 13.5 again, and I got 9.3. So there are my pieces of data. Again, go into the sheet and record yours. Okay, so one more voltage and current. Well, maybe I'll go somewhere around 16. 16.3 and 11.2 for me. Okay, so there are my pieces of data. Again, you record yours from the sheet in the Google Stream. Okay, now that we have all that data recorded, what we're going to do is convert this to regular amps. I'm going to leave that to you. And so go ahead and fill these in by making a conversion from milliamps to regular amps. So you're taking all these, converting them, and getting a set of values there. So go ahead and do that now. Okay, the next thing that you're going to do is you're going to plot the voltage versus the current. And that's going to happen right here. So what you're going to do is set up your axes. So that means, you know, the voltage will go down here and the current will go here. But remember, we need units, so make sure to include those. Don't forget, you need a title on all graphs. When you plot your data points, well, 0, 0 is 1. I'll just throw on some points like this. You know, you're going to have points like this, okay? And so what you have to do is you have to do a best fit line and get, well, of course, you're going to plot more carefully. I just, you know, you're going to see some kind of pattern like this. More volts, more current. What you have to do is draw a best fit line and calculate a slope. So I realized that I forgot my ruler. Give me 1 second. I'm going to run and get a ruler because we always use a ruler for a best fit line. Okay, so remember, we want to follow the pattern as best as we can. So what we're going to do is we're not going to go like this or like this. That doesn't match the pattern. Plus, we don't want to be have all the points below the line or above the line. We want to be as best as we can passing through the center of the trend. Now, I can't do this that carefully because I got the video camera in the way, but it's not bad. That's a pretty good best fit line. So there's my best fit line. And then over here in step 15, we're going to determine the slope of the line. Oh, so by the way, go ahead and plot your data now. Label the axes, title, data points, best fit line. Go ahead and do that now. Okay, so over here, step 15, we've got to determine the slope of the line. Now, in the instructions, it says it's 4 points. You need an equation, substitution, and an answer. There's 3 points. Remember, the substitution needs units. The answer needs units. Units have to be everywhere. Okay, so the equation, you could write slope equals change in y over change in x. You know, that works as an equation. Plug in points off the line, and then an answer. Now, again, remember, when you calculate the slope, I mentioned this early in the year, you do not use any of these data values. None of your points should be used in your slope calculation. Pick 2 new points on the line. This is like an average of the data trend. These are just individual measurements. So you want to always use the average, which is the line itself. You also don't want to pick 2 points close to each other like that. That magnifies the error. Pick a point near the beginning, near the end of the line, and calculate the slope of those 2 points on the best fit line. So that's the 4th point, that you're using your data points selected makes scientific or statistical sense in terms of the data trend. So go ahead and do that now. Calculate your slope. Now, the next thing is step 16 says the slope of your best fit line is either equal to the, oops, there's a typo, the resistant, no, the slope of, okay. this should say the resistance of the resistor. Okay, we measured the resistor up here, but something with this slope over here will equal the resistance. Either the slope is equal to the resistance or the slope is equal to 1 over R. It's one or the other. Try it out both ways from this number over here. And when you figure it out, then write out the equation and the answer right here for the resistance as determined by our experimental best fit line. So go ahead and do that out now. Figure out the resistance from only this value right here. Okay, so the next thing is on the next page, percent error in this box right here, right up here, box 17. So you have two resistance values. Here's one, here's the other. You do the percent error. This you could think of as the accepted, and this is the experimental. So go ahead and calculate the percent error in this box right here. Okay. All right, now the rest of the lab is just these three questions, which, should be pretty straightforward. So that was the Ohm's Law lab. I hope you enjoyed the experiment. I hope you enjoyed the video. I'll see you in the next physics video.